Did you know that JP Morgan Chase, one of the world's largest banks, uses none other than artificial intelligence to safeguard your transactions? But what is this machine learning algorithm that is so powerful that it is powering services like home loans, wealth management, inventory management, and financial advisory? This algorithm is so powerful that JP Morgan Chase has even built a quantum version of it to make it smarter and faster. Hello everyone and welcome back to my YouTube channel. I am Selina and in this week's video we are going to talk about none other than random forest. Yes, this is the algorithm that I was talking about previously in my video. So we will understand the intuition behind it by asking more and more complex questions as we progress in the video. We will also see a mathematical explanation and end the video with a Python implementation in Colab. So let's jump right in. Before we start learning about random forests, it is important to know the concept behind decision trees. So if you haven't already watched my video on the intuition behind decision trees, I have put a link in the description box below. So please do check it out. It will help you understand the concept of random forests even better, and it will make you understand why it is so powerful. So what is a random forest? A random forest, as the name suggests, is a forest of decision trees. It is multiple decision trees whose values have been aggregated to formulate a more accurate and stable result. Let us understand this with an example. Imagine that you are in a completely new city and you want to try out a new restaurant. So you have multiple friends in the city. And when you want to try a new restaurant, you won't just base your decision on one person's idea of how a restaurant is. You will take multiple opinions rather than just one. And that is the entire idea or gist behind random forest. You take the value provided by multiple decision trees rather than just one decision tree. A single decision tree can be overconfident, or it can make bad decisions because of the limited input that it was given, just like one person's opinion for the restaurant. Random forest was introduced by Adele Cutler and Leo Bremen in 1999. It includes two key features which make it different from decision trees, and those are bagging and random selection of features. Let us understand these two features in more detail now. So now we know that we need multiple decision trees to create a forest. But how do we do that? How do we create this forest of decision trees for our random forest algorithm? Well, for this, Leo Bremen introduced the bagging algorithm in 1996. It is also known as Bootstrap Aggregation. And the key idea behind this is to create multiple decision trees by taking different random subsets of data from our original data set and training the same decision tree on it multiple times. Let us now understand bagging or bootstrap aggregation with this example. So we have our original data set, and over here we have used multiple colors so that you can easily see the distinction in data. Next, what we are doing is, for creating multiple decision trees that vary amongst each other, we are selecting random data sets from our original data set. So the subsets we are creating are absolutely random. This is called bootstrapping. So like this, we have created sample 1, 2, 3, 4 till n samples. And for each sample, we are making a different decision tree. So this is our learning model 1, learning model 2, 3, 4 until n it goes. And at the end, we just aggregate its value. To randomize these trees even further, random selection of features was introduced to these trees. So in each tree, there were different levels, and at each split, some features were used. But for every next tree, they used a different random set of features at each level to split the tree. This introduced more randomness and unevenness to the data and to the trees. Let us now understand the process of randomized feature selection with an example. So let's say that you want to predict whether you will buy a smartphone or not. So you have your data set with all of your training data, and then you need to select the features. This is feature selection. In this, there can be features like what is the price, how is the camera quality, and how is the battery life, and so on. Next step is to randomize these features. So for each new model or each new decision tree that you make, you will use a different set of features everywhere.
For each split starting from the root node, you will use a different feature so that you can create different models of decision trees to create more unevenness in your model and in your training. And finally, you will do the voting to get the final result.
The formation of random forests is different for classification and regression tasks. For classification tasks, because usually we have a binary output, hence we use majority voting, in which we take the majority value or result provided by multiple decision trees. In case of regression, usually the output is a number, so we average the result of multiple decision trees to get the output of a random forest. Finally, let's take a look at a Python implementation of random forest using Colab and scikit-learn.
We first begin by importing the necessary libraries. So we have load iris, then we have train test split, random forest classifier, accuracy score, and classification report. Next, we load the iris dataset that we will be using to implement the random forest algorithm. Over here, we have two variables x and y. X represents the features like petal length, petal width, sepal width, etc. And Y represents the target, that is the species that we are predicting, which can be either setosa, versicolor, virginica. And then later we split the dataset into training and testing. Over here, as the test size is zero point 0.2, this means that 20% of the training data is being used for testing and 80% is being used for training. Next, we create a random forest classifier model. In this, we assign the random forest classifier to a variable RF classifier. Over here, we have given the parameter n estimators a value of 100. This means that we will be creating 100 decision trees and then aggregating the value of it. Next, we train the model on the training data by using RF classifier dot fit function on xtrain and ytrain. And then we make the predictions using RF classifier dot predict on xtest. After this, we evaluate the model's performance by using the accuracy score metrics on ytest and ypred. And then we form the report using classification report. Now we are printing the results. Over here, as you can see, we have achieved 100% accuracy and we have also achieved the classification report. Let us now understand the classification report in detail. So, a classification report provides the key metrics that help you understand how well a classification model is performing. These include precision, recall, F1 score, and support. Precision, recall, and F1 score for Setosa are 1, 1, and 1, and even for Virginica and Versicolor. As you can see, all of these values are 1. This means that we have got flawless performance in our report. Let us now visualize the confusion matrix for our random forest classifier. For this, we are using Seaborn as SNS and matplotlib.pyplot as PLT. And once again, we are creating a confusion matrix using sklearn.metrics. Over here, we have the confusion matrix for our random forest classifier. The rows over here are our real values and the predicted ones are the columns. Over here you can see actual, Virginica, Versicolor and Setosa. Then you can see predicted Setosa, Versicolor and Virginica. All of these values in the diagonal are non-zero. This means that for every actual value of Setosa, the predicted value was also Setosa because we have 100% accuracy. So all of our predictions were right. Similarly, in the case of Versicolor and also Virginica. Let us now look at the most important features of our random forest classifier. For this, we are creating a variable importances using dot feature importances and feature names using dot feature names. Over here, you can see that the petal width was the most important feature and the least important feature was the sepal width. This importance score is ranging from zero point 0.0 to 0.45.
That was all for this week's video. I hope you enjoyed it and were able to understand the intuition behind random forest and what makes it so powerful. I'll be back next week with another intuition behind another machine learning algorithm. If you like this video, then don't forget to like, share and subscribe. Till then, thank you for watching and see you again next week.